This is section 9.3, system of linear equations. So now we're moving on to more than just two equations and two variables. Moving on to three equations and three variables. The whole first, I'm not going to read that out to you, but here's a couple examples of some systems. The first thing we're going to do is use back substitution. Now the goal is to get your system to look like this example right here, where there's an xyz on top, a yz in the middle, and then a z at the end. Because you could take that z and back substitute into the other equations to solve. I need a thin marker today because there's a lot of writing. So I'm going to take this and plug it back into that one. 4 times 3 is 12, subtracted from 8, and we get that y is -4. So now I'm going to take -4 and 3 and plug it back into the first one. And then here we get x plus 17 is 22. X is 5, so the answer is 5, -4, 3. In whatever order they put it in, usually 95% of the time it's going to be x, y, z. All right, here's the method. Are you ready? Okay, first step, you have to get rid of the x term that is in this spot. That is the first step, is to get rid of that x term. We're usually going to use the method of elimination to get rid of it. So I'm going to choose to use the first equation and multiply it by a 2 and add it to the third row. So I'm going to take 2, -2 actually, -2, multiply it by my first row. I'm going to do rows and circles and add it to row 3. I'm not touching rows 1 or 2, so I'm going to recopy them down. Because I'm not touching that. I'm using row 1, but I'm not actually changing anything. I am changing the last one. So a -2x plus a 2x is 0, so there's no x term in the bottom. So -2 times -2 is 4. 4 plus 4 is 8y. Remember, I'm using row 1. -2 times 3, which is -6. -6 minus 7 is -13z. And then -2 times 1 is -2. Plus 11 would be 9. Here's my new set of system. Now I'm going to go ahead and work with the first two rows. I need to get rid of this x term. That's the second spot to get rid of. It's like you work your triangle backwards. So I'm going to get rid of that spot. So I'm going to take a negative row 1 and add it to row 2. So now I'm not actually changing rows 1 and 3. I'm changing row 2, but I am using row 1. So I'm not going to do anything to it. Recopy it. And recopy row 3. I am changing the middle row. So a -x plus x goes away. Negative and -2 is +2. 2 and 2 is 4y. And -3 plus -1 is -4z. And then -1 plus 13 is -12. Oh, that's not true. It's +12, not -12. I was just so used to saying negatives. +12. All right, so now the next step is to get rid of this y. Well, I'm going to use row 2, because if I use row 1, then I'm putting an x back into my equation, so I have to use row 2. So I'm going to multiply -2 times row 2 and add it to row 3. I'm recopying everything that I don't change. So it's just rows 1 and 2. I am using row 2, but I am not changing row 2. So -2 times 4 plus the 8 is 0. -2 times -4, which is +8. 8 plus -13 is -5. And then -2 times 12 is -24. -24 plus 9 is -15. Now I can back substitute. Well, z is going to be 3. Because I could just substitute that. I could plug that, or I could solve that little mini equation. Pick up. Y is going to be 6. Ooh, negative 12 plus 9 is negative 3, so x is 4. And my answer is 4, 6, 3. Okay, I think I'm only going to do one of every kind, and then that should be enough. And you can work on these in class. So then it also talks about how there could be different options. Same thing with our two equations, two variables. There could be no solution, infinitely many, or one solution. Well, we did the one solution. This one's going to be no solution, but it's the same process. I need to get rid of that 2x first. So I'm going to multiply negative 2 times row 1 and add it to my row 3. Going to recopy my 2 rows. I'm not actually going to change. So negative 2x plus 2x goes away. Negative 2 times 7, which is negative 14. Negative 14 plus 7 is negative 7. Negative 2 times negative 7 is positive 14. Positive 14 plus negative 9 is 5. And then we have negative 2 times 3 is negative 6. Negative 6 plus 10 is 4. Oops. Not just right, it's smaller now. Now I have to get rid of that 3x. So I'm going to multiply row 1 by negative 3 and add it to row 2. So I'm not touching the first one. I'm not touching the last one. Touching the one in the middle. So negative 3x plus 3x goes away. Negative 3 plus 7, or times 7 plus 14 is negative 7. Negative 3 times negative 7 is 21. 21 plus negative 16 is positive 5. Uh-oh, looks like they're almost the same. And then negative 3 times 3 plus 17. Oh, that looks weird. Negative 9 plus 17 is not 4. Oh, it shouldn't be. That's right. Just kidding. Just kidding. Negative 3 times 3 is negative 9. Negative 9 plus 17 is 8. Okay, one more step. Oh, there were pictures here on the left-hand side that show you what they look like graphically. So now I'm going to take negative row 2 and add it to row 3. All right, so negative 7 plus 7 is 0. Negative 5 plus 5 is 0. Negative 8 plus 4 is negative 4. Well, does 0 equal negative 4? No. So this is no solution. Then here's one with infinitely many solutions. We're going to do one of these. We'll do A. So hopefully I have enough room to get A done. So I need to get rid of this 3x. So I'm going to take negative 3 times it by row 1 and add it to row 3. Copy down the first 2 rows because we're not actually changing them. We're only changing the last one. Negative 3x and 3x go away. So then we get 3y and 9y, which is 12y. And we get negative 15z and negative 21z, which is negative 36z. That's a big number. Then we get 6 and 18, which is 24. It's okay if they're big. It's okay. So now I'm going to multiply negative 3 times row 1 and add it to row 2 to get rid of that next 3x. So negative 3 plus 3 is gone. Then 3 plus 1 is 4y. Negative 15 plus 3 is negative 12. And then we have 6 and 2, which is 8. In the last row, if you look, this row is now, they're similar, the last two rows. So I'm going to take row 2, times it by a negative 3, and add it to row 3. My now job is to get rid of that 12y. Recopy the first two rows. All right, so negative 4 times negative, or negative 3 times 4 is 12 is 12 is gone. That's a 0. Negative 3 times negative 12 is negative positive 36 plus negative 36 is 0. So that's a 0. And then negative 3 times 8 is negative 24 plus is 24 is 0. So this means infinite, which now we need to actually set more variables to variables. So I'm going to assign that z is equal to t. This is like standard stuff. All right. And I'm going to take my t and plug it in for z and solve for y. Okay, so y is equal to 3t plus 2. So now I'm going to take what my y is, what my z is, and plug it into the first one. All right, so x plus 2t minus 2 equals 2. X equals negative 2t. Is that right? Negative 2t. Oh, plus 4? Plus 4. Add 2 over. Yep. All right, so the actual answer, sorry that I'm working my way back up. Negative 2t plus 4 is our x. Our y is 3t plus 2. And z is t. So that's saying that you could take any value, plug it in for a z, and then find what the corresponding x and y parts would be. That's what that means. And then one word problem. We have John. He receives an inheritance of $55,000. Financial advisor suggests he's putting it in 3 different mutual funds: money market, blue chip stock, and a high-tech stock farm. Each of them have different returns over the years: 5%, 9%, 18%. And he wants his first year to have a return of $4,650. And it says to avoid excessive risk, he decides to invest 3 times as much in the money market fund as the high-tech stock firm. Okay, so we have money market, blue chip, high-tech stock. So our system, we're investing our $55,000 in those 3. Then we have our returns. And we want our return to be $4,650. And then lastly, it says he wants x to be 3z. So I'm going to change this last equation so that it looks like the rest. Okay, now I can use a system. I'm going to get rid of that bottom x, this one first. I'm going to take negative row 1, add it to row 2. I'm not going to touch row 2. So I'm going to recopy that one down too. So negative x and x go away. Negative y, nothing is negative y. Negative z and negative 3z is negative 4z. Negative 55,000 and 0 is negative 55,000. All right, now I need to get rid of this piece right there. So I'm going to times negative 0.05 x to, oh, not x, just negative 0.05 times row 1 and add it to row 3. 2, row 2, row 2. So my x parts go away. Negative 0.05 plus 0.09 is 0.04y. Negative 0.05 plus 0.18 is positive 0.13. Negative 0.05 times 55,000 plus 4650 is 1,900. And then we have row 3 still. Okay, so I'm going to get rid of this piece now. So I'm going to multiply it by 0.04 and add it to row 2. Oh. So I'm going to take my row 2 and add it to 0.04 times row 3. So my y's go away. 0.13 times negative 4, oops, plus negative 4 times 0.04 is negative 0.03. Oh, that's just an equal sign. And then we have 1,900 plus 0.04 times negative 55,000, negative 300. So we can solve for z. So divided by negative 0.03, and z is 10,000. I can plug it back into the second equation. Oh, that's an equal sign. And we get that y comes out to be 15,000. Well, if 10,000 go in one account, 15 in another account. Oh, we know the other one had to be 3 times it. So 3 times 10,000, x is 30,000. And these three amounts do add up to 55,000. And that is the end.